Hi Edith, welcome to AI Remix.
Hi, nice meeting you.
We have a series called AI Jam where we just talk about everything in tech, however possible. So,
Well,
can you please tell something about yourself for our audience, Edith, like so that they can get to know you?
I'm basically industrial engineer with
Mm-hmm.
a second title,
Mm-hmm.
a little operations research and stuff like that. It used to be uh, an interesting subject. My first job
Mm-hmm.
after master's degree was had to do with data analysis, and
Mm-hmm.
it used to be done manually back
Mm-hmm.
then, 1982.
So, in a pen and a paper and whatnot, and everything. So you had to skip through like the whole
Yeah,
book of
yeah,
files, like all the
right,
files,
right.
every document, read every
And
page, everything.
and 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 I gauge what belongs to what and reorder it in some way. And
Uh-huh.
that's the way it used to be done. And there was no solution. I get into the subject already because I got finally some algorithm that
Mm-hmm.
worked very well. And later on, I tried it again and again. I worked in different places.
Mm-hmm.
It started in the United States,
Mm-hmm.
and then I continue working on it in Israel in different subjects. Every time I used it, the results were better than expected.
That's so good to know.
So
But what did that
no,
algorithm do?
it can't be. It can't be basically because the theory is always less perfect than reality.
Yeah,
So
that is true.
I knew that there is something in it,
Mm-hmm.
but I'm not a scholar in this respect. I had to invent the things from start. It
Mm-hmm.
started with an algorithm that worked.
Mm-hmm.
And then I had the chance to work on it seriously when I was on a research grant in Singapore.
Mm-hmm.
And again, results were surprisingly good and effective. And I ran against the statistics
Mm-hmm.
department, the head of department of statistics, which hated my approach. And
What was that approach we are talking about?
non-statistical. You can imagine.
I can
Uh,
imagine telling a data story without data is tough.
without the statistic approach,
Hmm.
because the whole thing was based on groups, and
Hmm.
there was I didn't invent it. There was something called group technology at the time,
Hmm.
um, but it didn't have my algorithm. It used different algorithm, and it was confined only to problems on the floor, on the production floor.
Hmm. So
And
I'm
but
assuming.
I took the name. I took
What's
the
the name?
name, but group technology. GT stands for group technology. Actually, I took the
Ah.
name and uh, infused it with my algorithm.
Nice.
And but the name was good because
Hmm.
the patterns
Hmm.
are the basic thing that is missing in statistics. You put everything in one place. All the data is put in one place. According to my
Either
theory,
it is processing of data, or it is the data itself which gets processed. Is it so?
well, uh, it is the data itself, but
Hmm.
the first step that you do is split it into hierarchical groups.
Hmm.
And it has to be hierarchical because if you know how to split data into groups, you know how to take each of the groups and split it further. So if you have a real pattern finder algorithm, you can do that, the hierarchical thing.
So like step 1, step 2, step 3, step 4, step 5, step 6, step 7, step 8, or it could be step 1, sub step 2, sub step 3, or whatever,
well,
you know.
This is the technicality, and I rather leave it to the end. But you ask about my record. I was playing with this for decades, like since the project in Singapore was 2002.
Wow, and, that's like 21 years back. Damn, I could not talk then, I'm guessing.
I thought that it's already pretty much can be used right for other projects as well, but it didn't. So I came back to Israel. I was involved in, I think, about 5 or 10 projects since then, in different subjects, completely different subjects. And again, the same thing happened. It always was ready, was able to find some, you call it, hidden patterns of interest and solve problems that other experts couldn't. So I got encouraged, and it was a subject that I have no idea about, like chemistry or pollution or even genetics. I have no idea, not before and not after. I'll come to that.
The thought process of thinking through things is an algorithm, correct?
Yes, it's algorithm.
And that is what you worked on, a thought process to collect data which is required to make some database decisions. Correct me if I got it wrong.
Yes, even more specific, to find the indicators that you can follow and control a process through them.
Makes sense. So like when we have, if data is step 1, we put pointers and connectors to that data to process that data. And those pointers and connectors
not
help
exactly.
us process data ahead.
Well, the processing is my work, and it's iterative process, takes time, and I do it offline on a chunk of data. I bring it. This is a general procedure. I bring it to the client for discussion to see which of the patterns is of interest and which is just already known and of no interest. So then I focus and do the drill down, and the drill down ends with some kind of indicators and insights. The insights are extremely interesting, and the indicators themselves, you can look at them as two pieces. One piece is root causes, and another part is the follow-up indicators, the ones that you should follow to see if a risk is imminent, or say you can, if you have to do something. Each of the indicators is related to an action that you should take.
Makes sense.
It's not my business anymore. It's the client that does it, that implements it.
Of course, like you built for the client, right?
Yeah.
So it's only.
So I was busy with this. At the time, I thought in different directions, even language. There was one area that I'm still thinking of developing, using the same approach for text for text quality control, sort of. especially in the large libraries that are operation libraries, like operation procedures libraries. Those are extremely lots of conflicts in them because it's text and it's written through many years by many people.
And then,
so you have
everybody has their own version of that text also, if someone wrote the first book, someone else will write a summary to that book. Someone else will write a summary to that book. Someone else will write a summary to that book.
Yeah, a lot of problems. I think that, so people always have this hope or fantasy that a very smart artificial intelligence will come and make sense of all this thing. It doesn't happen.
It actually is already doing that. That input isn't that input the sense itself?
Well, I hear a lot about ChatGPT. It can't resolve conflicts. It can bring you the common text or the common thing, but it doesn't resolve conflicts. And it doesn't tell you what should you do for the next thing you write.
No, that is true. And it normally also, let's say you say the message 1 and message 2, which the replies come from ChatGPT. There's no relevance between message 1 and message 2. It only replies back. It doesn't keep a memory of that conversation there, That's the problem with ChatGPT. Also, it's awesome. It can reply to everything you ask, but that a series of questions, it cannot keep a memory of that series of questions in that conversation. Sometimes. What do you think?
So it's another field that I want to concentrate on in the future. I just going to write an article about it. I'll send you a link.
No, I will. Yes. So, Edith,
it was the first project that I was involved in with big data. And it was a project that I ran with the chief scientist of Israel. Then it was many years ago. There was only one chief scientist. And it used to help startups of various kinds. And I was lucky to have his participation in it. And I think that the model is still valid. Not far ago, I just taught it in the Engineering Association of Israel. It was a big class on the same year. And they didn't know why I'm so... Those professionals that need to write procedures, work procedures, didn't understand what I'm so excited about. Not even a day.
It is building a system. If we don't have
because it's not only quality. It saves you about, according to experiments that I did, it saves you about 80% of writing any new thing, and it will be more trivial and more easily adopted.
And see, sometimes users. You know what I see? What I see there is, instead of what we generally do is, if we don't know about something we're going to write about, we simply just Google it or try to look for some reference in the book, try to make sense of it for ourselves on how it probably makes sense, and then we write it down, right? Don't we?
Yes.
But that's where, if you think about it, if ChatGPT has written something, it is like the summary based on multiple articles. And then that summary, we can make sense out of that summary for ourselves and do something from it differently also, What do you think?
Myself, I don't go this way. I always write the headlines first, and the line that I like to pursue, this I write it first. Then I look how it corresponds with existing material.
Mm-hmm. Wow. And then, see, if you think about it, that also puts the thought process in a constraint on which you want it written. Putting a headline there would make sure we don't lose our focus on whatever the topic is. Correct? Is that why you do that?
Yes. And in order to have an objective, or to keep a different, to start from a question that is unanswered, and build it in some way that is objective and can be scrutinized. Either my approach is not so good, or some others I have what to say about them. It sort of puts some proportion, objective proportion on just looking.
If we think of it like that, all of this, if we summarize, okay, your that becomes a very good data dignity process. Like whatever data you want to write about, whatever data you want to research about, whatever data you want to process, that gives a shape, an architecture to get it written or built.
It is right. It is very much true. Yet I'll add to it another kind of wishful thinking.
Please do.
Right. You come to a project with an idea. All right. And on the other hand, you have everything that was said on the subject by others. Okay. And on top of all, you have the data, impartial data, that says whatever it says. It has nothing to do with anybody's idea. And I like to get started from there. When I do data analysis, I start from there, from what the data has to say, what the pre-notion, the pre-notions about the subject are considered, but indirectly. I just add them to the data. Like say 1 + 1 is equal to, I add another column. One column will be data 1, another one will be, and the third column will be 2. My answer as a pre notion about the subject. My answer is 2. Now let's see what the answers that were given in reality, and interpret them.
Makes sense. So in that we also get a way to look at data neutrally, a way to look at data, wrong data, and the way to look at right data.
You say it better than me.
No, I am just listening to you and trying to summarize that.
There is, yeah, and the philosophy behind it is what Professor Joseph Agassi was insisting. He was philosopher of science, a very famous one, and he lived not far away from where I do, so I had the chance to discuss it with him many times. And there is one principle in his view that I try to really follow, which is be critical of everything. To be critical. And there is no final answer or the true answer to anything. Every hypothesis needs to be checked and rechecked and revalued.
Now that we say it, I agree to it also. But there is this one way we look at things also, right, Edith? Nowadays, data has become such a complicated word also. See, I'm trying to make sure we don't lose focus from our topic, which is data.
Yes.
And then also,
it's complicated.
The point I'm trying to make is, see, data practices help analyze a situation better. Once we understand the situation better, we can kind of find a more critical and a more optimal solution for that situation we are in. So, like the AIs we talk about today, they are based on a direct end use case without considering data, or data is considered and we see an AI built around that. What do you think?
Yeah, I do agree that it's a process.
Logic first
it's
or
not
data
a one
first?
answer.
Okay, like logic first, data first.
First data.
First data
Data
and
is a
then logic.
sacred thing. Yes, and one shouldn't screen data or a priori play with the or choose or sample. Even not sampling is not allowed. Whenever people sample the data before they give me, I find missing pieces in the analysis. There are missing pieces that I need then to ask and complete.
And in that, what happens is that gives us a perspective towards what that data is trying to tell us properly also. Like sometimes the data is stating some things from which we need to derive a story. Data's job is not to tell the story, data's job is to state the facts on which we get critical and build a story. Is it so?
Yes. Interpretation, you mean?
Yeah, interpretation. See, data says the Earth rotates around the sun.
Right.
And we also observe that. So the data which we are stated, which is a fact, and the data which we see and we interpret. Like I just gave a very holistic example. I don't know why.
Okay, I have a more specific example later if you wish. Because I thought that the subject of us today would be fraud and how to detect and how to identify and how to better do.
How can we do that? Like what can you tell three basic tips for any day-to-day user that he doesn't get stuck in data fraud? Like not a computer scientist, not a computer engineer.
Yeah, of course.
A day-to-day user like you and me, other than our profession.
Which is always the case.
Yes.
Because I don't overload the client with all the theories that behind the findings. Just give him what he needs for work, and it will better be simple.
So that's what.
No,
like, do you have any three tips for users? Like, do you have three tips for users on what they should do?
Only one.
What
it's
is
only
it?
One. Maybe two. All right. It has two parts. When suppose you went through the agony of analyzing everything and getting to the insights and practical diagnostics and indicators that you want to implement in your system. So it depends what is your system. I may give you a piece of paper with a list of characteristics of patterns of interest, and part of them are numeric or alphanumeric.
Correct.
Characteristics of the groups of the patterns of interest. And what are the indicators? Indicators, it's always in plural, always few of them together that make a phenomena. It's
Index,
not only one
syntax,
indicator,
like to simplify it for everyone, index or syntaxes can be the indicators.
Yes.
Like let's say we are looking at a world map. The index of the world map is the indicator for that data, which is the world map.
Yes.
Or we are looking at a graph. Graph would have
it would be indicators that it has to be very easy and fast to perform because you want to catch them while they happen.
Correct.
Without burdening the system.
Makes sense.
You like to be. So this is also, it happened to be the results. So
no,
in any
it's
case,
a small
it
process in a larger process set, which makes sure whatever we're trying to do is happening in a way with data, right? Like the indicator which I set up is a very small process to work on the data to make sure we have control over what analysis of the data we're doing and what we're trying to derive
it's
from
not
the
the
data.
analysis. It's not the analysis that you as a client wish to have, I guess. It should be the, I guess it is in most cases, just leave me alone. We don't want to be involved in analysis. Just tell us, give us an alert, an early alert when it's going to happen. And we know the best how to treat this case. But we want early alert in real time. So my alert should be very fast one, and how you can reach it by really giving them just those risk or opportunity,
like a
groups.
litmus test.
Yeah, you know how to
like a litmus test. Like we get a litmus paper, put it on different things, we see if it is acidic, basic, or neutral. So like we decide those three different variables for the indicator we create. So don't think of it as only a litmus paper, but like that litmus paper, we have the power to put characteristics to that litmus paper when we build a new indicator. Is it?
Yes, but it's not on just right or wrong. It's not
no, of course,
like
of course, of course.
right?
That's what, right?
It tells
Three
you to
variables,
which
four
group,
variables.
and there are many groups, multiple kind of diagnostic.
No, makes sense, makes sense. And Edith, just let's talk about fraud which happens around data and what's conventional wisdom to get into less frauds.
Right. First of all, the point where people get sort of losing some of the effectiveness of the method is is when people use their experience and their knowledge as a starting point. Now, once you say that, it is as if you said, I have to wait until I have enough knowledge about any phenomena in order to study. It means that you are always one step behind events.
Makes sense.
That's the point.
No, like we kind of need to build some assumptions about data for them to be right or wrong or relevant or irrelevant towards whatever our data is. If we don't build that assumption, there is no data story.
Yes. And the point, another point is sometimes you do have the right answer, but you cannot prove it. Again, if you cannot prove it, doesn't exist.
And if it is based on data and you cannot prove it, then it doesn't exist.
Right. That's a problem.
It's a maths equation, right? Like where we are saying 1 plus 1 is equal to 2. We are saying 1 plus is plus, but it is doing a function of multiplication. Then 1 into 1 becomes 1 only.
Yes.
So knowing and processing data is very important. I get it. But can you please talk something about conventional wisdom towards data fraud and making sure we don't get ripped off on data?
Well, it has to do with the model and the principles. And the principles that, as I said before, the first principle is don't touch data. Data is sacred. And another second, I think, or the third is, first of all, break the data into patterns. Only when you can presume some kind of homogeneous data, only then you can start apply statistics. Before then,
makes sense. And
right.
in that, what happens is when we don't touch the data, we build a layer of what our understanding of the data is in this process, and we process that ahead. Right? Like instead of messing with the data, we mess with what our understanding is of the data and process it ahead.
Yes, we see it through our pre-assumptions, and then you miss everything else.
No, but that also helps us not cross represent, but go through the data again based on whatever our presumptions or assumptions are, and we can kind of fill in the blanks there.
You can go backward. After you have the good answer, it's very interesting to go backward and see where was the right answer under my nose that I didn't see it first. And usually it's interesting. And every project I have this practice that once I get the results, I compare them with what I could see with the same kind of understanding if I used statistics. If I see the results of statistics, I know that people didn't make a thorough enough work. But many times you don't see it in statistics. So then I know that I discovered something. Because I'm an outsider, I'm an analyst coming to a project where smart people were working for years on, They know very well the data and many of the phenomena that go on there. So it's interesting to see what they are missing because of their method, because they're using statistics. So if you see something in my method and you don't see it in statistics, I know that I discovered something that is significant.
And we can add the statistics to it.
And then you add it. Not always it's possible, because if it's a rare case and involved a very particular preconditions for happening, like it could be in fraud, then you can't prove it with statistics at all.
Then we have to make sense of the factual information in the data to make sure it is a fraud.
Yeah.
See, our assumption that it can be a fraud over it is a fraud or not are two different things. Right?
You see a pattern that is I have an example later if you have enough time.
We got 40 more minutes. No worries now.
Okay. So first of all, yes, there is this process that you get to results and you get to an insight over the results. Insight is sort of expansion of the results that you can put your hands on. Then you have sort of extension of it. You say, if it was on this type of date of circumstance, why? Let's see if it works on a different group. And why it doesn't work on it? If it doesn't work, why?
Then see, in that what happens is, like, please correct me if I'm wrong. Let's say we have data set A and data set B, which are very similar. We look at data set A, we derive a process, and that process works. So what we do is we try to replicate that process on data set B also. And then sometimes it doesn't make sense. It's only logical. If it is similar data set, we are going to end up doing that. Right? Like if we have already spent an effort to try a process out, why not try that process first and then, if need, build a new process?
Yeah, And this way you get ahead of the fraudster. Why? Because suppose
you have both the sides to see from. One is the factual side, one is your analysis, and there's two data sets there.
Sometimes you catch the fraudster in his preparations, and he's doing it only on small cases, suppose. And this becomes the characteristic of his fraud, of his attempts to fraud. And still, he didn't accomplish anything, but you are already on his tail. So, as I say, you already sit on his case. So you say, well, here are all the characteristics of his, and there is no reason why it will be only on small scale.
No, makes sense. And
so you eliminate this characteristic. It shouldn't be only for small cases, and then you extend your perception. You say, now we are looking for any case, small or big. This is already implementing insight in your work.
It is.
And this is how, suppose it's a new technology that the fraudster is using. And you say, well, he's using it now, but there are other opportunities. Maybe he'll use it there as well after he's successful.
Okay, Edith, just to make our users or the listeners' lives better, can we kind of name some types of frauds we can come across? Like basic phishing links. I brought some links which we don't know, we shouldn't click them.
I don't have it in form of links.
No, just as an example, Edith.
Yeah, I'll give you, I have a few of them. It has to do, most of them have to do with money, because this is the easiest.
Makes sense. Money has a value on which people worry about fraud. In a way.
I have a small example with a local bank in Israel. Another example of polygraph. It's not money. About polygraph trying to figure out who is saying truth, who is saying lies. So polygraph is a lot of data, especially if you have 4 or 6 channels of polygraph detecting the vital signs of a person. It's quite a mess. Then I have an old example, but I love it, from New York Stock Exchange 2000. Just a short time before the .com exploded. And then I have another small example from local elections in Israel, where some suspicious irregularity that was then substantiated with experts on the matter.
What's the form of the examples you have? Like, how are those examples? Are they in pictures, or is it a story, or do you have something written about it?
I have something written. All of those examples and some more were taken from presentations.
So now, tell me this, please. Like,
it's a long way from the raw data.
No, I understand that. I understand that. So, because I want to add that to our conversation, the examples you have, when you send them to me later, I'll just put them here, like right here, somewhere here. You'll see it.
Tell me what you need, and I'll send it. I'll be happy to share it.
Just send me some examples on what some of our audiences can read through.
Okay, I have some. This local bank is a very nice example.
Is it handwritten? Like, can you just show it to us? If it is handwritten?
It is. I'm reading it now from something that I picked from a written presentation. But just to give you a sense of how how this process works. So first, just you observed in cases that were resolved, that were detected. You observe through this tool of GT group technology, through this algorithm, you observe that the suspicious pattern has some characteristics in common, and the characteristics were that it was large sums, that the large sums were pouring into new accounts, not regular, but new accounts, and the accounts were registered on the name of a family member of the one that makes the transaction. Now the picture gets clearer or more suspicious. And then they used particular, particular billing services or clearance services to do these transactions. And then I had another little hint. The wave of this kind of pattern started in a specific date, which corresponded to the date where the new regulation in Israel came to life, into effect. So now I had already, even an outsider doesn't understand banking, I had already kind of a story. Of a suggestion.
No, it makes sense, and it kind of starts painting a picture for you on what is happening based on the data.
Right.
And in
exactly.
that, there's just to kind of make this situation an example more fun. If we can sometimes there were 2-3 things which you mentioned when you got the data. Let's say the person who's doing the transaction is person ABC, but the account is registered under the name of XYZ. That, if we look at data from some countries, that happens on a very generic scale with a lot of people because of, give or take, 4 reasons. One is the cultural way of how they look at things. It is because of how they look at things culturally. It is because of how tech educated they are. Sometimes, like, let's say someone older to me doesn't know how to use a phone, would do their transactions using my account because they need to get it done. There's this one.
They wanted to look like a regular transaction because they themselves have something that is already been on the suspension list or something.
No, I get that, but like the point I'm trying to make is the basic data which you have, that let's say there were these 3 things happening. The account holder did not have his name. There's a pattern of transactions from this date to this date. And there's this one thing which flagged something to you. Like the account user name and the account user are 2 different people.
Well, the data itself includes a record of data, includes hundreds of pieces of information, hundreds of them. And the benefit of running this algorithm is that it chooses for you, it allows you to focus on, let's say, 4 or 5 indicators that only if they all happen at once flag an alert.
No, makes sense. But in that, what happens is we as people who are working towards building these systems need to consider a lot of things. Like the place where that account is getting made, in what conditions that account is getting made, why is that happening?
Not each of them by itself is innocent, is no problem. But together, they create a picture. Only together. This is the idea. Like in statistics, usually you check the factors one by one, and you assume that they don't interact. In my case, just the opposite. They all interact all at once. They don't exist by themselves, only together.
No, makes sense. Like
just the opposite, to make a point. But that's not the end. What's here? Then they get, once you have those suspicious patterns, then you get to some kind of drill down and validation, logical validation, not statistical, still logical. You go to research. What's going on there? You still need some to know better about it. Yeah. So in this case, I discussed it with a girlfriend of mine that worked in a particular department where they were had the control department. So she told me, and this is how I build the rest of the story. The sort of business that behind the transaction is found to be just a small business, doesn't justify the large sums of money. And there is hardly anything going on in this business. Visiting the place. Then the transaction maker partners have another similar even by name, but another similar by function, similar account with another bank. And in the other bank, they were already listed as not a good account, with over $1 million shekels in debt. And the partners themselves were arguing and on the court with this kind of disputes among them. So it was a real kind of starting to smell not good. And the older people in the bank recall that there were other cases that had this pattern, and they all ended with losses to the bank. So, needless to say anything more.
And
but there was something more. The question is, what I wrote about it something. I picked some. So the question is how to prepare for the next step, not even to allow those people to get close to it. So you can identify those cases, at least get them into a risk group that needs more questioning. And the data that you need to watch comes from different sources. One source is the transaction themselves from the bank. Another are the clearing houses. Then you have a particular credit card attributes, like the region in the country from where they are coming. Because it doesn't make sense sometimes that such large money will come from almost forgotten kind of settlement somewhere. And fraudsters have some strategies
they try to build a story which they can sell, saying that is not a fraud.
They try to hide where there are many cases like theirs. So hiding in a crowd. And then you may look, or you have a log of transactions, false transactions didn't come through in the past. Maybe didn't come through because the fraudster was working on perfecting his method.
Makes sense.
So you catch him before he perfected it. That's even better. And of course you have the recommendations and the indicators that you already built. So this is how you build up a knowledge from ground to top, not from assumption to
makes sense. And see, assumption is the first step towards at least getting a perspective. But the moment factual data starts getting in place, we reduce the value of the assumptions we have built.
Yes.
Like
then
it's a vicious
data
cycle.
gets priority.
It's a vicious cycle, in a way.
It's not vicious. I see it one way, not as a cycle at all, because
it's a flow chart.
Knowledge is a general term of everything, data and assumptions and everything that you ever think. This is knowledge. And then you confront it with actual analysis. The good thing about this analysis is that it holds for years. It doesn't change that often, the general analysis. And when you have a new branch of new
it becomes a thumb rule.
Then it's clearly a different thing, and you don't need extension, to work that hard in order to characterize it anymore.
Makes sense.
So it gives you sort of a continuous,
and it gives a structure to solving a problem also. Like
right.
And that's like sometimes we might lose our thought process and whatever it is while solving a problem, getting too swamped, but that structure helps us get to the end of things.
And you can communicate this structure verbally, because it makes sense.
It makes sense.
At the end of it, a human being has to do something, to take an action. Hopefully, analysis is not fully automated, because
see, that's the thing, right? There's this one misconception around analyzing something and taking action on that analysis. People think analyzing things is an action, but it isn't. It is per se. In theory, it is. But my point is, like, there's always a step after analysis on what action blocks come on that analysis of data, correct?
Right.
Just analyzing and putting a full stop there is getting in a hyperloop of procrastination for solving some things.
It's like a detective story.
Like if you don't deduce things from the data, what's the point of being a detective there?
Right.
Like if you're just going to look at things and say just the way they are, just how it looks to your eyes, but not tell why it looks like that to you, the data is not going to make sense. And that why is the structure we were talking about on this is why there's this one account made, there's this another person's account name, there were transactions in a pattern, this was a pattern last seen by this type of fraud, then that pattern was kinda,
and fraudsters they copy from each other.
Yeah, they do.
Sometimes they copy. They don't invent everything from start.
And in that, it is easier to catch someone like that. I get the point on conventional wisdom towards fraud detection now.
No, the beautiful thing is that it saves time also.
It does.
Because, it does. Because I'm not pretending to understand the business. And the person that has the user knowledge doesn't need to understand analytics.
Makes sense.
We meet at the point of where we try to rationalize the results. And sometimes says, this I know. Okay, so you know it. I didn't know. It's good. So we level up.
And then there's this one insight from the user side, and there's this one insight from the fraud detection side, which gives a final relevant answer to it.
Yes.
So that the user side data tells you a generic pattern of using that software, and we compare the generic patterns which we have seen in probable fraud. If those patterns overlap, match, they give us some output based on whatever the data we've collected in either of those patterns. Is it?
And sometimes you may ask also, sometimes, how come the user didn't see what's... this is a very important question. You have respect for each other. Like, you have respect for the user. And you ask yourself, how come he didn't see such a simple answer? Because it's simple. When you get to it, it's...
I get you what you're trying to say.
You have to agree on the payment up front, because once they see it, they say, we knew it all the time. Of course, there is knowing and there is knowing. So,
and it is fun,
suppose
where we
you
look
need
at
to
the data.
answer how come. Yeah, you need to answer the question out of respect to the user. How come he didn't see the answer? And the answer for this question is very interesting. Sometimes it's because some capability that his system doesn't have, or some kind of the history of there is an answer to it.
There always is, because what happens in that is we either get a outlook to look at finding an answer, or we get the answer once we follow this process.
But no matter what is the process, the answer needs to stand criticism.
Critical criticism towards looking at a situation.
It has to stand on its own, no matter how you got it. It has to be explainable, and real people need to use it. Now, there is a great benefit when you do this way. It's a little humble approach, but it has one benefit, which is really... first of all, because of the hierarchical, I didn't say it before, the hierarchical structure of the groups makes it possible to get through the groups to the upper groups and see what are the initial circumstances or factors that enabled the whole thing to become a problem or a risk.
And in that, what happens is...
So you get to the source, to root causes, in a way.
And
this is...
It's navigating through the process, step by step in every way.
Right. And when you get to this, to the final, when you reach the final result that you think are okay with the algorithm, and it's a self-review process, the final results, they split to two. About half of the results you can implement right away, and I'll tell you why it happens so easily.
Because there's a hierarchy set in the process. So like in the earlier steps of the hierarchy, if you find something in the data, that can be implemented in the whole process.
Not only that, but not everything can be controlled. Some things are in the system. But the other reason why half of the problem can be avoided is because you look at multiple causes that all have to happen at once. If they don't, and in particular circumstances, if they don't happen in once, it doesn't happen.
Makes sense. So it's legit like a flow chart. We have to fill in the blanks to a flow chart of a process.
Yeah, you look at through, I'm still at the logical sense of... if you have multiple reasons that have to occur at once, and you take out one of them, it doesn't happen. So this is the way to control. You don't need to control everything.
It's like there's a guy standing. It's like saying there's a guy standing there, but where is there and what is that? And who is that guy? These questions need to be asked to get all the steps ahead. Like just as a very vague example, Like
if the same person stands somewhere else,
all those variables change.
Yeah. Even if they're staying the same, still the event wouldn't happen. The event
makes sense.
Okay.
No, it does make sense. Okay. And we kind of need to wrap this conversation now, Edith, because we will run out of time again and we can go on and on and on and on and on talking about this. But to summarize whatever Edith says.
The polygraph was a very cute case.
So in that, like, it is an analysis of data about our impulses in a pattern, which says if we are lying or we are not lying, correct?
Right.
So, like, to summarize whatever Edith said and what we spoke about today for our users, I want to kind of wrap this, right, like, say a small summary so that we can wrap our episode and we can still keep talking. On this, but we kind of need to put a cap on this for now.
Very good. Very good.
Thank you so much for coming to the podcast, Edith. It was great to have you on AI Remix. Edith essentially was talking about on how we can get into less data problems and keeping ourselves safe from all the data frauds which happen around and the conventional wisdom around it. As a data scientist or a securities engineer or a person who is even building a software, these are the things we need to keep in our mind so that once we see user patterns, once we see how the creation what you have built is getting used for and what it is getting used for too, it gives a perspective towards that also, doesn't it, Edith?
You summed it up very well.
Thank you so much, Edith.
There is so much more to say about it because it's a very interesting world.
Can you just give me one pickup line for good data practices? Like one line conventional wisdom. One line of conventional wisdom.
There is one.
Uh-huh.
If you're going to analyze data, first try to include every pieces of data if they are not frequent even or side data. And then first thing you should do, no matter which way, try to group them, because the grouping, even if it's not right, can give you some interesting point to inquire.
Makes sense. So at least clustering something will tell you if the clusters are right or wrong, or relevant or irrelevant. It puts us on a thought process, and then that process only sorts everything ahead if we follow the basic thumb rules, right?
Yeah, it's sort of a shortcut that many times leads you to nothing, but it still has potential and opens your mind
to look at things from a different holistic sense.
Right.
Makes sense. And it was awesome to have you on the podcast, Edith. We will talk about this again. It is always my pleasure hosting you. Thank you so much, Edith.